titration method. So today we're going to focus on complexometric titration. I don't care if you guys know or don't know about complexometric titration. So today I'm going to tell you about complexometric titration. So complexometric titration is a technique by using EDTA to determine metal ion concentration. There is a few applications. For examples, for food industry, they detect calcium in complex. For plastic industry, they will detect nickel. For metal industry, they are going to detect etching solution. For the pharmaceuticals, they are going to detect aluminum hydroxide in antacid. For today's research, we are going to tell you about the water hardness, which is the determine Cl2+ and magnesium 2+ by using EDTA.
Alright, so here's how we run our water hardness test. So step 1 is we put a fixed volume of water sample into a conical flask. And step 2, ammonium chloride buffer was added. Why? Because you have to maintain the water pH at around 10, not too extra and not too basic. And step 3, a few drops of aerochrome black tea indicator were added, and then the solution gonna turn wine red. And don't drink it even though it is wine red. And then step 4 is titration. The sample was titrated with standardized EDTA solution while we swirled the conical flask. And then 5, finally the color gonna change from wine red to pure blue, and that's when we know how much the EDTA will use. And then step 6, the volume of EDTA were recorded. And step 7, of course, we're gonna do the calculation to carry out to determine the concentration of calcium and magnesium. And finally, the values were converted into CaCO3 equivalent, and that's how the total water hardness were determined. Easy, right?
Now, I will explain how complexometric titration can be applied to determine water hardness. Hardness mainly comes from calcium and magnesium ions and report as milligram over liter as calcium carbonate equivalent to make comparison easier. As we can see here, we got two results that we found in internet. In this slide, I already conveyed the concentration of calcium and magnesium to milligram over liter as calcium carbonate equivalent. So we look at table 1, which is mineral water. Calcium contribute as 72.67 and magnesium is 12.93. So it giving a total hardness which is 85.6 milligram over liter as calcium carbonate equivalent. According to World Health Organization, it can be classified as moderately hard water. So for table 2, can you elect it much more lower than table 1, which is calcium is 5.08, magnesium is 1.88, and total hardness is 6.96 milligram over liter as calcium carbonate, and it can be classified as soft water. Let me ask you, did you guys know which sample do you think will cause more scaling to appliances like kettles and pipes? Yes, of course, mineral water, which is moderately hard because it produces many calcium carbonate. And for your information, mineral water also safe for drinking because it have many minerals like calcium and magnesium, which is good for our body. So it shows that complexometric titration is very important in daily life to compare and monitor water analysis.
As we know, we are using complexometric titration in this research. But why we are using this method in this research? There are 6 advantages of using this method. First, we can ensure water purity. accurately measure Ca2+ and Mg2+ ion. Second, it can prevent household problems. By using complexometric titration, we can reduce the lump scale and soap scale, so we don't have to deal stubborn dirt while washing our dishes. Third, protects appliance that can prevent scaling in machines and pipes. Fourth, accurate and reliable. By using EDTA, it will form a stable, complex, and clear endpoint. Fifth, they are cost effective. As we know, complexometric titration using EDTA, where EDTA is simple and inexpensive reagent. And lastly, environmental benefit. By determining Ca2+ and Mg2+, we can reduce the overuse of chemical and prevent pollution.
So after all the swirling, dripping, and the dramatic color changes, we finally success to determine the water hardness by using this complexometric titration. So we tested two samples. So the first one is mineral water. It was classified as moderately hard, which is 85.6 milligram per liter as CaCO3. And while the second sample, which is clear lake water, was classified as soft, which is 6.96 milligram per liter as CaCO3. So this shows that this titration is reliable, accurate, and widely accepted methods to use